Welcome all to the next session of Optical Communication, that is Easy 405 in GATU. Today we will start with our second module. Before coming to this session, if you didn't go through the first module, then you have to see the first module discussion. You can get that from the description that I will be providing. So in the second module, we have to go through 13 sessions like fiber materials, its fabrication, a special type of fiber, that is photonic crystal fiber, index guiding PCF, photonic bandgap fiber, fiber cables, then optical sources like LEDs, laser diodes, its structure, characteristics, modulators using LED and laser diodes. Then we will see how to couple the produced light to fibers, various noises present in laser diodes, amplified spontaneous emission noise, and effects of laser diode noise in fiber communication. Today, I will discuss the first session, that is fiber material. So when we talk about fiber materials, we need to deal with different materials based on our requirement. So first of all, I will discuss what are the basic criteria for selecting a particular material for the fiber fabrication. So the first criteria is that it must be possible to make long, thin, and flexible fibers. It must be transparent at a particular wavelength to guide the light efficiently. There should be physically compatible materials which offers slightly different refractive index for the core and cladding in such a way that, as we know, the core should be having higher refractive index when compared to cladding. So while assuming that N1 is the refractive index of core and N2 is the refractive index of the cladding, then the materials that is to be added or dropped in core and cladding should be in such a way that N1 should be greater than N2. So these are the three main requirements that should be considered while selecting materials for fiber fabrication. The materials that satisfy these requirements are glass and fiber. So glasses are the most widely used fiber materials. See, we will discuss the use of this glass and plastic by considering its various features. First of all, when we consider glass, as you know, it is very less flexible. Flexibility is an issue when we consider glass, while plastic offers more flexibility. When we consider about the attenuation, glass is offering very less attenuation, while plastics are offering more attenuation losses. Mechanical handling of the glass fibers like gripping and crimping is very delicate. As in the case of plastic, the mechanical handling like gripping and crimping is easy when compared to glass. We can use the glass fibers for higher temperature range, while plastic can be used only for low temperature range. As the glass is offering very less attenuation loss, we can use the glass fibers for long distance communication, while plastics are offering high attenuation loss, and therefore we can use plastic fibers only for short distance communication. And we be using plastic fibers only in those areas where we can't use glasses. So first of all, we will see the types of glass fibers, where in glass fibers the main constituent is SiO2. So types of glass fibers are glass fibers, halide fibers, active glass fibers, and chalcogenic glass fibers. In the case of glass fibers, we need to add, as we had discussed just before, we need to add some dopants in order to vary the refractive index. If and only if we can vary the refractive index, then only we can create a core and cladding separately. This GeO2 and P2O5 will increase the refractive index of SiO2, while B2O3 and fluorides will decrease the refractive index of SiO2. The second type, that is halide glass fibers. The main feature of this halide glass fiber is that it offers very less transmission loss. Here, the core is constituted by ZBLAN, where cladding is by ZHBLAN. Active glass fibers. See, this is very important, very important classification of fiber, since this type of fiber we will discuss in detail in module 5 while we are dealing with fiber amplifiers. So this type of fiber, that is active glass fibers, offers strong magnetic and optical properties. The dopants are rare earth elements like erbium and neodymium, which is the most commonly used. There are other type of rare earth elements like thulium, ytterbium are also used for various applications. The last type is chalcogenic glass fiber. It offers higher optical nonlinearities, and its named because chalcogen is the one of the most important material used for fabrication of this type of fiber. So as I had said earlier, we be selecting various types of material based on our requirement, that is where we are going to use this type of fibers. So in the case of glass fibers, just before I had discussed that we are using GeO2 and P2O5 for increasing the refractive index. This we will be choosing based on the graph shown. As you can see, that in the graph, the x-axis is dopant percentage and y-axis is refractive index. From this graph, it's clear that GeO2 and P2O5 will increase the refractive index as the concentration, doping concentration increases. In the case of B2O3 and fluoride, as the concentration doping increases, it will result in decrease of refractive index. Now the second material, that is plastic. We have high bandwidth graded index polymer optical fibers. See, graded index. In the first module, we had discussed that we are using graded index along with multimode fibers. So it's clear that, see, usually plastic fibers will be multimode fibers. In plastic fibers, there are very popular plastic fibers. See, in plastic fibers, we are having two type of fiber based on the material or the type of plastic we are using in the core region. First type is PMMA plastic optical fiber, where PMMA is polymethyl methacrylate. PMMA plastic optical fiber, where PMMA is polymethyl methacrylate. And the second type is PF plastic optical fiber, where PF is perfluorinated. So these are the types of fibers. In the next session, we will discuss fiber fabrication.